Hello, students. Today we are going to talk about geometric sequences in algebra, but first we have our do now with a question about people who are different from each other, diversity. Our objective will be to learn about geometric sequences, and we'll be thinking about and answering the question, what is a common ratio and how do I identify and continue a geometric sequence? So some new terminology there today. Our assignment will be to complete the do now. We have 2 pages of notes and an application at the end. We're going to summarize the lesson, complete the exit ticket. If you're a distance learner, you need to submit photos of your work in Teams. If you're in person, you can just show me your work. So tonight you'll do homework 9, geometric sequences. And we have 2 important due dates coming up. One is the interactive notebook and then our unit test. So I do have a little fun street art for you and a diversity puzzle if you finish early or you have some extra time later and you're just looking for a little break. And then for our exit ticket, we will answer the question, what is the geometric sequence formula? And I'm hoping that you can memorize it by the end of the lesson. So for our do now, we have our question, what are some characteristics that culturally diverse people are likely to share? And I think where we're headed with this question is even though people can be very, very different from each other, there are things that they can share, like maybe great food, good music, kindness, love for one another, love for family. So I want you to think about things that culturally diverse people have that they share that could be the same. And please answer that right here. So we're going to talk about geometric sequences today. So a geometric sequence is a sequence of numbers in which the ratio remains constant. And we use the letter R for the common ratio. So the common ratio is found by dividing each term by its previous term. Actually, there should be no apostrophe there. So we're going to start by identifying a geometric sequence. Then we'll continue geometric sequences. So our task first is to determine whether the following sequences, these 6 sequences, whether they are geometric. And if they are, we will identify the common ratio. So I have 2, 10, 50, 250. So what do we do to get from 2 to 10? We multiply by 5. 10 to 50, we multiply by 5. 50 to 250, we multiply by 5. So yes, this is a geometric sequence, and the common ratio, or R, is 5. So number 2, we have the numbers 135, 45, 15, 5. So from 15 to 5, we divide by 3, or we could say multiply by 1/3. Will that work for 45 to 15 and 135 to 45? Well, it does. You might need your calculator for this. So this does make it a common, a geometric sequence with a ratio of 1/3. Now, number 3, to get from 6 to 18, we multiply by 3, but to get from 18 to 24, we multiply, we're adding 12, so we multiply by 2/3. from 24 to 30, we multiply by 1/3. So something different is happening in each one of these numbers. So this is not a geometric sequence. Number 4, we have 7, -14, +28, -56. So what we're doing here is we are multiplying each one of these by -2 to get to the next term. And since they have a common ratio, it is a geometric sequence, yes, and the ratio is -2. So number 5, we have 80, then -40, then 20, then -10. It's easy to see that we're definitely multiplying by a half, but when we go from positive to negative, negative to positive, and positive to negative, that means that our ratio is -1/2. So we went from positive to negative, that will require a negative. From negative to positive, that will require a negative. So the last one, we have -9, -36, -144, -576. In each case, we're multiplying by 4. In that case, we have a geometric sequence, and our ratio is 4. So now we're given some geometric sequences, and we are asked to continue those sequences. So 7 to -21, we're multiplying by -3. -21 to 63, we're multiplying by -3. So the next 3 terms would be a -189, a +567 times -3 would be a -1701. So let's look at number 8. And it looks like here we're dividing by 4. So we're going to divide by 4 to go from 3072 to 768. We're going to divide by 4 to get from 768 to 192. If we divide by 4 again, we will have 48. Divide by 4, 12. Divide by 4, 3. Okay, in this case of number 9, we have 8, then 4, then 2. So each one of these numbers is 1/2 of the number before it. So half of 2 would be 1, half of 1 is 1/2, and half of 1/2 is 1/4. And in number 10, we have -5, -125, -25, -125. So it looks like we're multiplying by a +5. -5 times +5 is -25. -25 times +5 is -125. If we multiply that by +5, we will have a -625. If we multiply that by +5, we'll have -3125. And multiplying that by +5, we have -15,625. So we actually have a formula that we can use to easily determine the nth term of any geometric sequence. So we did this before with arithmetic sequences a while back. This time it's geometric sequences. So the nth term of a geometric sequence can be found using the following formula: A sub n equals A sub 1 times r raised to the n minus 1 power. Now, what do these terms mean? Well, the a sub 1 term is the first term in the sequence, and R is the ratio. And then the N is the nth term that you want to find. So I think this will probably make a little more sense to you after we do a couple of these. So we need to find a rule for the nth term in each one of these sequences, and then we're going to find the 7th term. So first we find the rule, then we use the rule to find the 7th term. So if we use our geometric sequence formula on number 11, which is 3, 9, 27, we can write the rule that a sub n equals the first term, which is 3 times, and what's our common ratio here? Well, we have to determine that first. Everything 3 to 9, we multiply by 3. 9 to 27, we multiply by 3. So our ratio is 3, so we write that to the side. So we have the nth term we need to find is the first term, 3, multiplied by the ratio of 3 raised to the n minus 1 power. So let's actually find the 7th term, which is what they ask us to do. So the way we write that is a sub 7. Okay, we're finding the 7th term. So that would be the first term times the ratio raised to the power of the term we want to find, 7 minus 1, and that equals 3 times 3 to the 6th power, and using our calculator, that gives us an answer. 3 times 3 to the 6th power is 2,187. So let's do one more. Let's find our common ratio first. So to get from -4 to 20, we multiply by -5. To get from 20 to 100, we multiply by -5. So our ratio is -5. So a sub n equals the first term, -4, times the ratio, which is -5, raised to the 7 minus 1, or n minus 1 power. So we'll simplify that. A to the 7th term in the sequence, a sub 7, -4 times -5 to the 6th power. And using our calculator, we discover that that is 62,500. Now, because we are working with exponents, these numbers can get very big very quickly. So imagine you would not be able to do this unless you were Arthur Benjamin, that arithmetic genius, but you would not be able to do these by hand. It would be very, it would be very tedious and would take a long time. That's why it's useful to have a geometric formula to help us. So let's go on to number 13 and 14. Maybe you'll try them on your own. But it looks like we're going from 400 to 200 to 100, which means that our common ratio is 1/2. We're multiplying by 1/2, or dividing by 2. So our generalized formula, a sub n, will be 400 times the common ratio of 1/2 raised to the n minus 1 power. The specific formula is a sub n equals 400 times 1/2 raised to the 6th power. And when we evaluate that, we have 6.25, because remember, folks, they're getting smaller and smaller. Were you able to do that yourself? I hope so. So let's see what the common ratio is in number 14. So from 1 to 5, we multiply by 5. From 5 to 25, we multiply by 5. So our ratio equals 5. So our A sub n equals 1 times the common ratio 5 raised to the n minus 1 power, which equals A sub 7 equals 1 times 5 to the 6th power, 6th power. And let me write that a little more neatly. So 7 minus 1 is 6. And when we evaluate that on the calculator, again, that gets big very quickly. 15,625. Let's go on to 15 and 16. So number 15, we are going from -1 to -4, -4 to 16. So -1 times a +4 is -4. -4 times a +4 is -16. So our common ratio here is +4. And our formula, generalized formula, A sub n equals our first term, -1, times the common ratio of 4 raised to the n minus 1 exponent. Now, if they're asking us to find the 7th term in the sequence, which is what they're doing, that would be A sub 7 equals -1 times 4 to the 6th power, and that equals -4,096. Number 16. So let's see. Definitely dividing by a fraction, and I think if you divide 729 by -243, you're going to get a -1/3. And if you divide -243 by 81, you will get a -1/3. So our ratio is -1/3. So A sub n equals 729, our first term, times the common ratio of -1/3, and we'll raise that to the n minus 1 power, and that will be A sub 7, to find the 7th term, 729 times -1/3 to the 7 minus 1, or 6th power. And when we evaluate 729 times -1/3 to the 6th power, the answer is 1. So how did you do? So let's move on to number 17. 6 to -12. Looks like we're multiplying by -2. -12 times -2 is 24. So our ratio is -2. And our formula, A sub n equals 6 times -2 raised to the n minus 1 power. So if I want to find A sub 7, the 7th term of the sequence, I'm going to multiply 6 times -2 to the 6th power. You need to put -2 in parentheses, especially when you use your calculator, or it won't include the negative sign. And when you do evaluate that on the calculator, it will come out to 384. And now number 18, we have 8, then 12, and then 18. So it looks like we're multiplying by 3/2. because 18 times 3 over 2 is 12. 12 times 3 over 2 is 18. So our common ratio is 3 over 2. So our formula, we'll derive that. A sub n equals 8, our first term, times our common ratio raised to the n minus 1 power. So if we wish to find the seventh term, a sub 7 equals 8 times 3 over 2 to the 6th power. And that will equal 91.125. So now let's try our application. So the table here that I'm outlining in green shows a car's value for 3 years after it is purchased. So first we're asked to write a rule to represent the car's depreciation. So we need to find out what the common ratio is. So, from 10,000 to 8,000 and from 8,000 to 6,400. It's not a matter of adding, subtracting. It's a matter of what do we multiply 6,400 by to get to 8,000? Or what do we divide 8,000 by to get to 6,400? And what do we divide 10,000 by or multiply by to get to 8,000? And that answer is 4 over 5. And to get from 8,000 to 6,000, that ratio is 4 over 5. So our common ratio is 4 over 5. So now we're asked to write a rule to represent the car's depreciation. So that would be A sub n equals, and our first term is 10,000. Our first term times the common ratio of 4 over 5 raised to the n minus 1 power. And the value of the car after 10 years, let's figure that out. So our term that we want to find is the 10th term of the sequence. So we're going to make that A sub 10 equals 10,000 multiplied by 4/5, and then we have that n minus 1. 10 minus 1 is 9. So when we calculate this, 10,000 times 4/5 raised, 4/5 raised to the 9th power, that is $1,342.18. So let's just see if that car is reasonable. So that's the value after 10 years. The first year it was worth 10,000, then 8,000, then 6,400. So this certainly does seem reasonable. So I would like you to take a minute and summarize what you've learned here, write a sentence or two. And I also would like us to go back to our exit ticket. So what is the geometric sequence formula? Can you do it without looking? So the geometric sequence formula is A sub n equals A sub 1 times R raised to the n minus 1. Now, remember, A sub 1 is the first term, and R is our ratio, and N is the term that you want to find. So that's it for our lesson for today. I do have a little bit of fun here at the end of the lesson, and you have some homework. So we have some Tate Gallery street art that you can do for a few minutes just to de-stress. And then we also have a diversity puzzle. It's very cute. So remember, algebra is about plugging away every single day, staying with it, and practice, 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 which of course I know you're doing because as you practice, you'll be great.